Welcome you all to this video lecture. In this lecture, we'll talk about threads. This video will be covering about what is thread and multithreading, thread scheduler and its life cycle, so how to create a thread and what are the different methods that we have, and what is thread priority synchronization. To start with, we'll start what is thread. So thread is nothing but it is the smallest unit of execution within a program. Program is nothing but the process which is in execution. We used to call it as a program. So a single program will have a multiple units to be executed. So that units we used to call it as a thread. So we also call the thread as a lightweight sub-process that runs independently, where it will use to share the same memory space shared by that process. When in a single program, if we are executing multiple threads at the same time, we call that particular process as a multi-threading. So threads which will be executed simultaneously, more than one thread or multiple threads executed simultaneously, we call it as the multi-threading. By default, we will be having a process which will have multiple threads. So each thread runs independently, but it will share the same memory. For example, in our own system, when we go to start and just type monitor, in that if you click on this resource monitor, zoom in, so this will show you here it will be listing all the process which is in execution. When you check this, this is what we call as the process and each process is used to have the process ID. And then here you can able to see one column called thread, right? And when I scroll this, you can able to see many process which is in execution. These many processes being executed in my system, right? So when I click on this Chrome, just check the thread count is 48, which means that I have opened 48 tabs in my particular Chrome, right? So that particular each and every tab we used to call it as a thread. So 48 threads are executed in parallel. So that concept we call it as the multi-threading. So we can also take this one as an example here. Multitasking and multi-threading. We need to understand the difference between what is multitasking and multi-threading. In my system, I'll be opening the Chrome and I will also open the window, Word document and then VS Code. So each of these one we call it as a task. And together, if we execute all these things, we used to call it as a multitasking. When you take a single process, see this process 1, process 2, process 3. Process is nothing but the program which is in execution, we call it as a process. So Chrome is executing, Word is executing, VS Code is executing. So we call it as all these are the processor. All these are executed in parallel, we call it as a multitasking. When you take a single process, in that particular process called Chrome, I'll be searching for something in a ChatGPT and I'll be opening some PDF file and I'll be listening to an YouTube. So all these are a threads. So process is having some sub process. So that sub process we call it as a thread. So the process here, this particular Chrome is a process which handles. So this Chrome is a process which handles the 3 threads. And this we call it as the multi-threading. Single task is divided into threads, right? Hope I understood what you have clear with what is multitasking and multi-threading. The next one, we'll see what is the thread scheduler, right? So, thread, we all know what is this JVM, Java Virtual Machine, right? So, thread scheduler, which is a part of your JVM, right? Which executes the multi-thread on a single process. So, this JVM thread scheduler is responsible for executing the multiple threads in a parallel, right? Usually, the thread will have their own life cycle. So life cycle here, it will be having these. This is what is the life cycle of a thread. So new means the new. A thread begins its life in a new state when an object of a thread is created. So at this point, the thread is not yet started, it's just been created. Next one we call it the runnable. So after first one we create a thread. So that will just create a thread. Then we call the next method called start. Right? So the thread moves to the runnable thread. Next phase. That is the runnable phase. Here the thread is started to run and waits for CPU to schedule whether this thread might run or if some other thread in execution might run. Right? So next one is the running. So what this running will do is that when a scheduler picks a thread from the runnable pool, it enters into a running state. So the thread executes its task. So that is run method. We used to have some method called run. So inside that we write a task so that it will run. So from running, what it can do is that it can move into a different state. So move back to a runnable if field is called. It will move back to a waiting, this one, waiting state or sleeping or blocking state. Or even it may be moving to the terminated state also. From running, it can move to three different states. So here, when it comes for the waiting, a thread goes to a waiting state when it waits indefinitely for another thread's resource or signal or something like that. A thread goes into an waiting state when it waits for a specific amount of time. So that can be achieved with the help of some functions called wait, sleep, suspend. Next one, it will move to the next step, which is called as the terminator. So once a thread finishes execution, or if it is explicitly being stopped, it enters into a terminate state. So once it enters into a terminate state, it cannot be restarted. Attempting to call start function once again will throw an illegal thread start exception. So this is the entire life cycle of a thread. Okay. Next one, if I want to create a thread. So we used to have a normal class. Hope so you know how to create a class in Java, everything. Now we'll see how to make a normal class to execute as a thread. Very simple. We have two ways. One is by extending the thread class. So we have a default or the predefined class called thread in Java package. Either we can extend the thread class or we also have an thread interface. So we may also implement, so that thread interface we call it as the runnable. Either we also implement that runnable interface. So we'll see how we can create a thread. This is my normal class. So class single thread, if you just extends, just give this word extends and thread. So thread, which is a predefined class we have, just we are inheriting that class. So now this simple class will become a thread. Okay. Now what we will do is that what this class should do, we used to write in a normal method. So the task to be performed by this class need to be returned inside the function called a run function. So this particular class is just going to print some message called thread. So that particular task to be returned inside the run function. That's it. Okay. Now, whenever if I need to call this run function, how we are going to do that? So we have created the class that extends the thread. Then override the run method. This is where we used to put the code that the thread should execute. Now, in my main class, I'm just creating an object for this thread, st. Now, how will I call that one or how will I start this one? So, this particular line, if you remember the life cycle, when I give this particular line, it will create a thread. Just create a thread. Now, I need to start the thread execution. So, how I can do is that making use of the start function, right? Just use this object st.start, which will make your thread to move to the runnable phase. Runnable phase. Now, automatically when I give st.set, it automatically goes to that class and it will search for the run function. When it sees the run function, the thread will move to the running phase. Now the thread will be executed. So this is how we will be creating or making the class as a thread class. Right? One thing. Okay. Next one, as I said you, we also have the another way in which we can make the class as a thread. How we can do that? By implementing the runnable interface. We are not going to change anything. Only two things we need to do it, right? So class run thread implements runnable. Usually we use, if there is any interface, we use to implement it, right? Remaining run method will be there. Now, when you come for the main function, what we will do is that first we will create an object for this run thread class. Okay, RT. Now, to make this particular class as a thread, we will create an object for the main thread class. Okay, thread T equal to new thread, and then now we will pass the object of this particular class to my thread class object. Okay, so here RT is my class. To make this, I just pass this particular object to this thread. Now my thread class has been created, which means that this run thread has been converted to as a thread. Right? Is that clear? Now then I'll just start making use of the thread class object. I'll just start the thread. Okay. So this is how we will be creating a thread using the runnable interface. You might wonder that why we have this two techniques to create a thread. Why? Because for example, when we can extend the thread means, see, if there is a class, when you take this example, class, this to make this particular single thread class is a thread class, I'll just extend a thread. Think of that this particular thread already extends some other class. Then in Java, we cannot able to extend more than one class, which means that multiple inheritance is not possible in Java. At that time, if this class is already extending some other class, we may implement the runnable interface to make this particular class as a thread. Okay? So that is what is being given here. So if your class already extends another class, so here the Java does not support the multiple inheritance. So at that time you can make use of the runnable interface to make your thread class as the to make your normal class as a thread. So we have many thread class methods. So here I have just listed only the important methods. To start, as we said, it is used to start the execution of this thread, right? So run, where we used to define what the thread need to be performed. Next one, sleep. This will make the thread to sleep for the given time that we will mention in the millisecond, right? So nanosecond precision is also there. So then next one we call it the thread control. So what this thread control will do is that stop the thread immediately, suspend, which will suspend the thread and then resume. See, once the thread has been stopped, it cannot be resumed back. But when you suspend the thread means we are just at that time we are just making the thread to stop. And then you can again resume back the thread using the resume function. Next one we have the join. So what this join will do, we'll see with an example. So it waits for the current thread to complete its execution. So in that one, we have different methods so that I'll tell you. Then interrupt. So interrupt, which means it will just interrupt the current running thread. And then we have you can also make use of if you want to know about the thread, we have get name to return the name of the thread, set name to set the name, get ID to return the thread ID, get priority, what is the current priority of my thread. You can even set some priority and then you can know the status of the thread using the get state function, and you can check whether my thread is alive or not using the is alive function. So here I have taken one small example here, right? So this is my class, right? Class thread demo. So this is my constructor, and here this is just going to print some message. Okay. So here I have used the get name function to know the name of my thread, and then inside that I've used the sleep function. Here when a thread object is created, its state is new, right? So when you come back to this main function, thread 1, thread 2, I'm just creating two objects for this. But when you check, this class already exists here. So now this class by default it will act as a thread. And then next one, I'm just giving my names for my thread using the set name function, which where I insisted in the thread method, thread 1, thread 2. After that, I'm starting thread 1 and thread 2. Okay, so thread 1 dot start, thread 2 dot start. Here, I've created two threads. So here, multi-threading, which means each and every thread will be executed in parallel. So when I just think of that, two threads will be created like this. So thread 1 will be created and then thread 2 will be created. So here we use, as I said you, JVM, which will have the thread scheduler. So it knows which thread to start first and which thread to start next. So this thread 1 will be executing, will be doing its own task, and thread 2 will be doing its own task in parallel, right? So when I give thread dot start, it just go to this particular thread demo class, and then here we have the constructor. This will be called. Then immediately it sees the run function. Their first line it prints the name of the thread, and then it is just going to print the message as some loop I have given there, right? And then I also make use of the sleep function, which will make the thread to sleep for just 50 nanoseconds or 50 milliseconds. Okay. So when I call this one, what happens is that when I am creating an object for this, it will create a new thread. Okay. When I give this object, it will just go to the constructor and just putting thread created, thread created. Okay. And then I'm just giving the name for this. When I enter this run function, I'm able to see the thread get name, which is the thread one, starts with the thread one is started. Okay. And then thread two is status started. State is running, state is started. Here, this is the start. Okay, here we have given the start. So this will be, whenever I give the start, it goes to the start. It will just start the thread and then it goes for the run. So once it will get started, it goes to the run state and run function, which just means running phase, and I'm just executing the task whichever I've given there. So just printing the message. Okay. To be very clear, I'll just show you one more example here. Right. Very simple example I've taken. So class A, class CSEB created, and these two are the threads in parallel. So class A is printing some message called class A, and class B will be printing some message for class B. Right? When I give A dot start, thread A will also be started, B will also be started, which will be in parallel. When I run this code, you can able to see, when I click on this run, that is just executing it. You see here. When you check here, first class B. B doesn't know which thread will start. So class B is started. I'm just printing this particular message for 100 times. A for 100 times B. So B is printing. Meanwhile, if you see to that, class A is being printed, which means that it isn't executed in parallel. Class B executing, class A is also executing. So what that JVM scheduler, so inside the JVM, we have a thread scheduler. It knows when to execute which thread. So it is just starting the execution with CSC B thread, then A, then it will be shuffling to B, A, and it will be switching like this. This is how a thread will be executed. So this is the one example which I have given. And here we need to understand the two main functions, that is the sleep and join. Okay. So sleep, which will make you a thread to sleep or temporarily wait for some time. But when it comes for the join function, it will wait for that current executing thread to complete its entire execution. Right? So here we call the sleep as an checked exception. This is an interrupted exception. So here it releases the CPU but does not release the lock while sleeping. So wait means it used to have a lock on that particular thread. So which means that lock means first the thread will complete the entire execution, then only the next thread will join. Okay. Similar to it, when you see here, thread A is executing, thread B is executing, both are in parallel. If I just give A dot start, then again A dot join, A will complete its execution, then only the B will start. So just if I give A dot join, and then I will give B dot join. So whenever I am using this join function, uh, we need to give this inside the try catch block. Otherwise, definitely we used to have the exception. I'm just giving quick fix. So I'm just moving this also. Okay. Make sure that sleep or join function must be given inside the thread block. I mean, sorry, try block. So if I just run this one, so when you check here, first A has completed its thread. When I make use of this join function, A has completed its execution. Then only the B would have started. In between that, you cannot able to see any A being executed, right? So this is the main use of your join function. Okay, it is used to synchronize the thread execution. Waits for another thread to finish its execution, right? So here we have different join methods. It overloads the different join methods. So here you can mention how long your thread can wait, or the nanoseconds you can mention the time. But we used to have this first function. Okay, so we have seen an example with the sleep method, right? So here the same example I've taken. So sleep method, which will make the thread to sleep for a second, 50 milliseconds. Whereas when you take the same thing using a join function, so as we discussed in the previous example, it will wait for the thread CSC A to complete, then CSC B will be executed. Okay. In the same example, if I just give here, after this, if I give thread dot sleep for some 100 or 1000, just I'll just give 1000. Again, I'm saying to this, uh, making this thread B also to sleep for, no, just thread. And again, here the same problem. Just quick fixing it. It should also be inside the try block. Make sure that I'm just running this code. So you can able to see some small interruption within that makes the thread to sleep for a second. Okay, right? So this is making use of the sleep and join function, right? Now next comes the thread priority. You can even set some priority for the thread, right? So the JVM, so here thread priority is a mechanism that allows the thread to have a different levels of priority, right? So which can influence the order in which the thread need to be executed by a JVM. So we have some constants being defined inside the thread class. So minimum priority, maximum priority, and normal priority. Minimum priority is the lowest priority, which is 1. So then normal priority is 5. By default, all the threads will be set to the normal priority. Then we have the maximum priority as 10. Okay. So whenever we have the highest priority, the CPU will be given the preference to run that particular thread in the order. So we have some methods in the thread priority, set priority and get priority. Set priority is used to set minimum, maximum and normal priority. And we also used to have the get priority. You can able to see what is the level of priority for that particular thread. By default, for all the threads, the normal priority will be set, which means it will be default priority will be 5. Okay. So here we have an example for that. I've created 3 threads here: DS thread, Python thread, and then OS thread. So all these are just printing some message like data structures, Python and operating system. Now I've created an, so all these are the threads. I have just extended the thread class here, right? So I'm creating an object for all these things. Now I'm just giving the name for all my threads and just I'm starting it. When I'm just starting this one, you see here, thread 0, thread 1, thread 2 has been started. Python printed 2 times, then operating system, then Python, then data system. Do we have any order in this? No. But I can set a priority for this. Even when I set a priority, what happens is that that priority are just suggestions to the JVM and the OS thread scheduler. But we doesn't give the order. Why? Because if your JVM is using priority thread scheduler, then this priority will be followed. Otherwise, it will be executed in normal. But if you want again, if you want to execute first Python should be executed, then data structures then. The same example, what I have done here is that, see here, after setting the name, I've given a priority here, right? So D set normal priority. Data structure thread is going to have the normal priority as 5, whereas Python have given the priority as 10. Then OS have normal priority, which means now I've given the priority to Python. Okay. Now, if I start this, I'll tell you why I've used this join. I start this, what happens is that I'll explain this with the code itself. Okay. Okay, right? I have given the priority for this, right? So maximum priority has been given to Python. I'm just running this one. So you can able to see that first Python has been executed, then data structures, then operating system, right? So sometimes this order will also be changed. To prevent that one, you may also use the join. Okay. So as per the priority which I have given the highest priority Python. So Python thread has started first. This is how your JVM will work when you give the priority for your threads. Now I think the thread priority is clear. Very simple. Giving the priority for the thread. So how we can see? We have the constants there, minimum priority, maximum priority, normal priority. By default, that will have the normal priority that is 5. You can also even change by using the function called set priority. That's it. I hope so. This particular concept is clear for you. So what is thread, creation of thread, and what is thread priority. So in the next video, we'll see the remaining topics of the thread. Thank you.